A dipole's positive Q is located at 0b. Negative Q is at 0, negative b. Point P is at A0. The direction of electric field at point P is in A, positive x direction, B, negative x direction, C, positive y direction, D, negative y direction, E, no direction because the electric field is 0 at point P. And which of the following is the electric potential at point P? There are 2-point charges producing electric field at point P. The field produced by the negative Q goes into the negative charge, so it goes that way. The field produced by the positive charge goes out of the positive charge, and this one has the same magnitude because the two charges are same amount, equal distance away from point P. So the field would be the same amount. And then we have to add these two electric fields together by adding vectors. So I have to make a parallelogram, and then the diagonal is the sum. So the net electric field would go down this way, which means it's in the negative y direction. So the answer is D. For the electric potential at point P, we also have 2-point charges producing potential right there. And the potential produced by a point charge can be found using V equals to KQ over R. And we must plug in the signs for this charge because the electric potential is a scalar. That means we do not have to draw arrows. There's no direction. We just have to add the two scalars together. So the net electric potential would be the potential produced by the positive Q, K positive Q over R, and the K negative Q over R. The R would be the distance between the charge and the point P, the charge and the point P, which is the same for both. That means when we add these two together, we're going to get 0. So the answer for the second one is E. A hydrogen ion and a hydroxide ion are released from rest in a uniform electric field at the same time. Assuming that the ions are far away enough from each other so we can ignore any interaction between the two, and that we can ignore the gravitational force on the ions. A short time later, when the ions are still moving in the same uniform electric field, the two ions will have the same A, speed, B, kinetic energy, C, direction of motion, D, magnitude of acceleration, E, magnitude of net force. The two ions have the same amount of charge, but one is positive, the other one is negative. The charges are positive 1e and negative 1e. As long as the ions are still inside the same uniform electric field, the electric force they experience would equal to Q times E, same amount of charge Q, same strength electric field. So the force on the two charges would have the same magnitude. Therefore, the answer is E. Now let's look at the other choices. The ions do experience the same amount of force, but the forces are in the opposite directions. The force on the positive charge goes to the right, same direction as the electric field. The force on the negative charge goes to the left, opposite direction compared to the direction of the electric field. So the direction of motion would be different. So C is wrong. The two ions, they have the same charge, but they have different mass. So F equals to ma, they get the same force, they experience the same force, but they have different mass. Therefore, the magnitude of acceleration would be different. So the answer for D is wrong. Because they have different amount of acceleration and at the same amount of time later, the speed equals to VO plus AT. Starts at rest, different acceleration, same amount of time, so the speed at the end would be different. So A is wrong. And then the kinetic energy gain comes from the potential energy loss. And U equals to QV. For the two charges, the Q is the same amount, but the V is different. Because this is uniform electric field, we can say V equals to ED. Same strength electric field, but they would travel different distances because of the different acceleration. So voltage is different, kinetic energy gain is different, so B is wrong.